Hello everyone. Today we are going to talk about some best practices in software development. Software development is a complex and rapidly evolving field. It involves the development of large, complex software systems that are critical to the success of modern organizations. As software has become increasingly essential to businesses and individuals, the importance of producing high quality software has never been greater. Applying best practices ensure that the software meets the need of stakeholder, is maintainable over time, and contributes to the overall success of the organization. In this presentation, we will discuss the key best practices in software development, including software architecture, coding standards, testing, code integration, security, performance, and monitoring. The very first best practice lies in design and architecture phase. It is the process of designing the software system and defining its structure, component, and relationships. It defines the blueprint for how the software system will be built and how its components will interact with one another. Starting with choosing a suitable architecture that meets the need of the system, such as client-server architecture, microservices, or layered architecture. Second, make use of design patterns. There are various design patterns available like singleton, factory, adapter, etc. Using these patterns will help maintain consistency and reusability across the system. Third, design for the scalability right from the start. For example, make use of distributed system and load balancing techniques to incorporate large number of processes and data that might come in future. And lastly, plan for maintainability. Design the system with modularity and documentation in mind. This will help with easy and quick management of the system. Next is coding standards and code reviews. Coding standards are the guidelines that define how code should be written and organized. They cover areas such as naming convention, code formatting, and code structure. On the other hand, code review involves the evaluation of the code by the team members to identify errors, bugs, and area of improvement in the code. The best practices involves using automated tools to enforce coding standards and detect errors. There are various tools available like SonarQube, Prettier, etc. Using these tools will help catch the errors at the early stage and make the process fast and easy. Second, make use of version control system to manage code changes and other artifacts. Use control systems like Git, GitLab, Bitbucket, etc. that comes in handy while reviewing the code. And lastly, document the standards and share among the team members. This will help teams stay consistent and up to date with the latest requirements of the coding standards. Up next is testing and quality assurance, a very important step while software development. Testing involves systematic checking that the software system meets its requirement and functions as intended. On the other hand, quality assurance involves ensuring that the software system meets the required quality standards. There are various best practices involved. First, to develop comprehensive test plans and test cases. It will help cover all the aspects of the software system for thorough testing. Second, make use of automated testing tools. Use tools like Selenium to increase efficiency and accuracy of the testing. Third, use real-world scenarios. Use user input data in testing to ensure that the software system meets the requirement of the end user. Fourth, use a variety of testing techniques such as unit testing, integration testing, and acceptance testing to ensure that the software system is thoroughly tested. Lastly, test early and often to identify and address issues as early as possible. Another important aspect of software development is continuous integration and continuous deployment. This involves continuously building, testing, and deploying software changes. Continuous integration is the practice of regularly merging code changes from multiple developers into a shared repository, and then automatically building and testing the software to ensure that it functions correctly. On the other hand, continuous deployments involves automatically deploying software changes to production environment after they have been tested and approved. This helps to ensure that changes are deployed quickly and reliably, reducing the risk of errors and downtimes. The best practices involves using automation tools like Jenkins to build, test, and deploy software changes automatically, saving time and effort of the team. Second, make use of feature branches to isolate changes and reduce the risk of conflicts. Third, use a deployment pipeline that includes multiple stages such as development, testing, and production to ensure that the changes are tested thoroughly before being deployed to the production. We have seen quite a few best practices in different areas of software development. Can you tell me what happens if we do not follow best practices while developing software? Feel free to pause the video and think about your answer. Well, if we do not make use of best practices while developing software, it results into technical debt. Technical debt is the accumulation of the code that is difficult to maintain or modify. It can result from shortcuts taken during development or from the use of outdated technologies. Technical debt can slow down the development and make it harder to add new features or fix bugs. And hence, it becomes very important to manage technical debt by regularly refactoring code, updating technological stacks, and definitely by using these best practices. Now that you know the importance of using these best practices, let's jump to the next topic. Here we are going to talk about security and privacy. Security involves protecting the software from unauthorized access, use, disclosure, disruption, modification, or destruction. This includes identifying and addressing potential security vulnerabilities like SQL injection attacks, cross-site scripting attacks, etc. On the other hand, privacy involves protecting the personal information of users of the software system. While developing the software, the less experienced developers tend to keep security and privacy as their least priority. Instead, one should start thinking of security right from the start. The best practices involves using authentication and authorization. Make use of mechanisms like biometric, multi-factor, or role-based authentication to control access to the sensitive data or functionality. Second, use encryption techniques like hashing to protect sensitive data in transit or at rest. Third, implement access controls to limit the risk of authorization, unauthorized access, or modification. And lastly, use privacy by design principles to ensure that the privacy considerations are considered throughout the software development lifecycle. Moving on to the next best practice in performance and scalability. Performance involves optimizing the software to ensure that it runs efficiently and meets the performance requirements of the application. This includes optimizing algorithms, reducing memory usage, and minimizing input-output operations. Scalability involves designing the software to be able to handle increasing levels of load and demand and to be able to scale up and down as needed. The best practices includes first, caching. Use caching to minimize input-output operations and reduce loads on the server. Second, use scalable architecture patterns such as microservices or event-based architecture to enable the software to scale up and down as needed. Third, use load testing to ensure that the software can handle increasing levels of load and demand. And lastly, use profiling tools like Visual VM to identify performance bottlenecks and optimize code. The last best practice we will discuss is in monitoring and logging. Monitoring involves the ongoing observation of key metrics and events in the software system, such as response time, error rates, and resource utilization. Whereas logging involves the recording of events and actions that occur within the software system. This includes error messages, system events, user actions, and other important information. There are various best practices available, starting with defining clear objectives and matrices. Establish clear objectives and matrices for the key performance indicators that are relevant to the software system being monitored. This will help ensure that the monitoring and logging efforts are focused on the most important metrics. Second is to implement centralized logging. All logs should be centralized in a single location to facilitate easy access and analysis of the data. Third, use real-time monitoring and altering. It can help to identify issues as soon as they occur, allowing developers to act before they impact end users. Fourth, monitor at different levels. It includes application level, server level, and network level. And last, monitor both key performance and functionality. Monitoring should cover both performance matrices such as response time, throughput, and error rates, as well as functional matrices such as user activity, system events, and other important events. In conclusion, software engineering is a complex and dynamic field that requires careful planning, execution, and ongoing maintenance and support. By following these best practices in software development, teams can ensure that their software is functional, reliable, secure, maintainable, and scalable, and that the users have access to the support they need to use the software efficiently and effectively. Thank you so much for listening.